Welcome, algebra students, to the last lesson of our unit. It is lesson 3.3. And if you could kindly open your books up to page 79. We have a little bit of review to do on that page, so please follow along on page 79. We're going to be looking at factorization, and in this lesson by using those special products of algebraic expressions, so the three patterns, which we will review momentarily. To begin the lesson on 79, they take us back to 7th grade, where we learn factorization is the process of expressing an algebraic expression as the product of its factors. And we learn two methods. And the first one is shown in the example number 1. So you would take common factors out of an expression. So for example, you see 4p squared q plus 6pq squared. So each of those, 4 and 6, have a common factor of 2. They each have some version of p and some version of q. So out of each of those parts, you can take 2pq out of each one of those. So looking at 4p squared q, if I take 2pq out of it, I am left with 2, because 4 divided by 2 is 2, and p to the second, if I take one of the p's out, I'm left with just plain p. And if I take a q out of a q, there's nothing left. So 2pq times 2p, now plus I take 2pq out of 6pq squared. So if I take a 2 out of 6, simply divide. 6 divided by 2, I'm left with 3. P divided by p. Now remember, you just subtract exponents when you're dividing. That kind of goes away because there's only one of them. But q squared divided by q to the first, I subtract my exponents. I'm left with 1q. So then I have what they wrote after the equal sign, 2pq times 2p plus 2pq times 3q. So basically, you're left with 2pq times 2p plus 3q, because you don't have to repeat the 2pq. You just take the two things that you're left with and add them together. So it's like the reverse of distributing. You're working back to the beginning, and that's what you get. Now, grouping terms in number 2, you have an example, 10ax minus 35ay plus 8bx minus 28by. Now, if you look at all 4 of those numerals, 10, 35, 8, and 28, it's a different situation than you saw in number 1, because you can't take something out of each one of those. You can't take the same thing. So you divide it in 2, and you work with the first half of that expression first, the 10ax minus 35ay. From both of those, you can take out 5a. So 5a, if I take it out of 10ax minus 35ay, I am left with 2x out of the 10ax, and then minus 7y out of the 35ay. So that's the first part. Now to that, I'm going to add the next part, and out of 8bx and 28by, I can take a 4b. Those are common to both of those. So plus 4b times, I'm left with 2x minus 7y. So now, remember, we would take the 5a and the positive 4b and group them together, times what I'm left with, which is the same in each case, 2x minus 7y. So we learned that last year. Today, though, we're going to focus on using special products of algebraic expressions, because those two methods don't work all the time. So moving on, page 80, we're going to review the patterns from last lesson. So remember, a plus b squared is the same as a squared plus 2 times a times b plus b squared. The second pattern is a minus b squared. It's the same as a squared minus 2 times a times b plus b squared. And then we have a plus b times a minus b is the same as a squared minus b squared. So using those three patterns, keeping those in mind, we are going to factorize some expressions. Remember, factorization in this case is the reverse of what we just did the last two lessons. It's the reverse process of expansion. So you just reverse the patterns we followed. So, for example, you would start with this. So here's the reverse patterns. A squared plus 2ab plus b squared is going to be the same as a plus b squared. So you just take what we have up here and flip them. So the reverse pattern number 2, you would have something written in this form. A squared minus 2ab plus b squared would go to a minus b squared. So you just flip those. For the reverse pattern of pattern 3, you will be given a squared minus b squared would be the same as a plus b times a minus b. So you're just flipping the process of those three special patterns. You need to be able to recognize, though, that an expression has those patterns. It's very important. So with all that in mind, let's go to try it 11. And we have 16x squared plus 8x plus 1. That is definitely pattern 1. So I'm going to find the square root to determine a and b. So the square root of 16x squared and the square root of 1. So the square root of 16, of course, is 4. The square root of x is x. So 4x squared would be, as I'm working backwards. And then, so in this case, 4x will equal the a. Plus 8x, I'm going to get to that in a moment. But then, of course, the square root of 1 is just 1. Therefore, 1 is b. Now, looking at that middle one, remember, this middle one is going to be 2 times a times b. So, in this case, it's going to be 2 times a, which is 4x, times b, which is 1. And then it says we just took that 8x and we put it in terms of 2ab, and it worked. 2 times the a factor, which is 4x, times b, which is 1. So, and that's what, this isn't divided by a, this just means this is a and this is b. So now I put this in terms of 2ab. Therefore, the conclusion of all of this is 16x squared plus 8x plus 1 is the same, equals 4x squared plus 2 times 4x times 1 plus 1. That's the pattern. Now I know what my a and my b is, so I just use it, plug it into pattern 1. So that's 4x plus 1 squared, and that's my answer. That's my answer. Once I get here, and I know it's going to end up here eventually, I just need to do all that squaring. Now let's go on to letter B, where I have 9u squared plus 12uv plus 4v squared. I take the square root of 9u squared. Square root of 9 is 3. Square root of u squared is u. So there's my a, 3u squared. And then I do the same over here. The square root of 4v squared. Square root of 4 is 2. Square root of v squared is v. So I have 2v squared. So my a is 3u. My b is 2v, and I plug that in the middle. 2 times 3u times 2v. I'm going to go straight to the a plus b squared because that's what I need. So I have my a, 3u, plus my b, 2v squared. I go straight to this pattern, pattern number 1. Now in number 12, try it 12, we are going to be using pattern 2. Same as pattern 1, except here we have subtraction instead of addition, or we have negative instead of positive. But we follow the same pattern. I find the square root of z squared, which is plain z, so z is a. The square root of 64 is 8, so b is 8. I rewrite it. This step is important. I need to be able to see it. And I have something on there. So a little piece of cardboard. So I have z squared minus 2 times z times 8, because z is a, 8 is b, plus 8 squared. If I worked it backwards, I'd come up with this. But from this, I go to the pattern of a minus b squared. So I just substitute a, which is z, minus b, which is 8 squared, and that's my answer. One more example, following pattern 2, is letter B. 100m squared minus 140mt plus 49t squared. Again, the square root of 100m squared is 10m, so that's my a value. The square root of 49t squared is 7t. That's my b value. I plug it into the pattern. A, which is 10m squared, minus 2 times a, 10m, times b, 7t, plus b, 17 squared, or 7 squared rather. And then I just put it into the form of the pattern, which is a minus b squared, which is 10m minus 7t squared. Okay, that takes care of try it 12. Moving on, I'm going to go to try it 13, which uses pattern 3. Okay, pattern 3. And of course you see pattern 3 with a twist, but we'll wait a minute with that. So I have 64 minus k squared. Again, just like my other problems, I'm going to find the square roots of each of these to get back. So 64, the square root of 64 is 8, which is a. The square root of k squared is k, which is b. So 8 squared minus k squared is what I end up with, but I put it into this pattern, a plus k times a minus k. And that, we go from this to this pattern, and that's my answer for factorizing 64 minus k squared. Same thing in letter B, just gets a little more layered. So I find the square root of 4p squared. Square root of 4 is 2, square root of p squared is p. So 2p is a. Square root of 81q squared. Square root of 81 is 9. Square root of q squared is q. So 9q is b. So I write it in this form. I take my a and square it, 2p squared, minus b squared, which is 9q squared, and then I go from this to the pattern. 2p plus 9q times 2p minus 9q, and that is my factorization of try it 13, letter B. Now going on to try it 14, I said this is pattern 3 with a twist. Okay, let's see what happens. I have 5t squared minus 20. I can't do a square root of 5 or 20, so I first have to reduce each one of these by 5 to arrive at perfect squares. I always have to do this factorization with perfect squares. If I don't have any, I see if I can reduce them. By gum, I can. I can reduce each of those by 5. So I end up with 5 times t squared minus 4, because 5 divided by 5 is 1, which I don't record. 20 divided by 5 is 4. I circled the 5 because I put the 5 on the outside of this, and I have to keep that. I have to keep that. I don't have to do any more with it, but I must include this as I go along, and you'll see why. So now I just use t squared minus 4, and I go through the steps. The square root of t will be a, which is t squared will be a, so t is a. The square root of 4 is 2, so 2 is b. And now you see where that 5 comes into play. 5 times t squared minus 2 squared, and then I take this within the parentheses and put it into the pattern, which is t plus 2 times t minus 2 but I need that 5 also. I have that extra layer, and that is my answer. So sometimes you need the twist. You need to reduce your initial product to get to perfect squares, and then you go through the steps. Pattern 3. Okay, one final problem. Try it 15 on the page 82. Again, we're going to use pattern 3 because it's a number squared minus a number squared. In this case, they tell me what A is. A is 463, B is 453. So my pattern is A plus B times A minus B. So I'm just going to take my A and my B and plug it into the pattern. So 463 plus 453 times 463 minus 453. Well, when I add them together, I have 916. When I subtract them, the difference is 10. 916 times 10 is 9,160. Okay, now remember, you can rewatch, rewind, pause as often as needed to understand what's going on. As you can see, when I reviewed how we did factorization last year, it might come back to you a little bit, but really the focus is on factorizing using these special cases and being able to recognize an expression that has them. So today, your assignment is on page 82, numbers 1, 2, and 3 only. You're basically not going to be using pattern number 3 today. Maybe you are. Yep, you will. You might not be using the special cases today. We'll see. 1, 2, and 3 is your assignment for today. Thank you, and do good math.